Hey everyone, welcome back. We are in grade 6. We're on unit 7, lesson 4. And before we dig into the unit, we're going to refresh ourselves on something that we learned way back there, like the first week of school, factor puzzles. So, one of the problems is 8 over p equals 14 over 21. And you might recognize that immediately that I immediately put it into a factor puzzle. Now, if you can't remember, if you're like, oh, it's been so long since we've done that, I can't remember what to do. Not to worry. Let's walk through it together. So remember, we're going to ask ourselves what a common factor between these numbers going both in the rows and also in the columns is. So what's a common factor between 8 and 14? Well, hopefully you're saying 2. They're both even numbers. It's got to be 2. So we're going to put a 2 there. And then if you remember, because it's in the 2 row on the multiplication chart, we're also going to put a 2 there. Now we say, okay, it's in the 2 row, 2 times something, some column gives us 8. 2 times what gives us 8? 4. Well, if it's in the 4 column, that means all the way up and down it's in the 4 column. So we put the 4 there, and we also put it down there. Now we're at 14. It's in the 2 row. 14 times what? 2 times what gives us 14? Well, 7. So it's going to be in the 7 column. 7 times 2 is 14. So if it's in the 7 column, then the bottom number is also in the 7 column. Now we're down here. 7 times something gives us 21. Well, we must be in the 3 row. 7 times 3, where 7 and 3 cross, is 21. So if it's in the 3 row there, it's in the 3 row there. How do we figure out what's that missing number? Well, you'll notice 2 times 4 is 8. 7 times 2 is 14. 7 times 3 is 21. So what's 3 times 4? It's got to be 12. Is that feeling like you remember it? I hope so, because one of the ways to solve these ratios when we're comparing ratios is to use factor puzzles. So they're going to invite us to try a strategy with factor puzzles, and they're going to make it a little bit trickier. Instead of just these whole numbers in the whole number rows and columns, we're going to see what happens when we are using ratios that may be fractions. We can actually have fractions, either fractions bigger than 1, like improper fractions, or regular fractions. And so it'll get a little bit trickier, but we wanted to refresh on how to do these factor puzzles before we dig into the harder stuff. Now, before we erase, there's something else they want us to look at. They want us to notice something that we call using cross multiplication to solve a proportion situation like this. When we look at these numbers, notice there's a pattern here somewhere. Here we have 2 times 4 is 8. Down here we have 7 times 3. So we have 2 times 4 and 7 times 3. Do you notice anything else about these numbers? That has the same numbers in it, doesn't it? This is 7 times 2. So there's the 2 and there's the 2. There's the 7 and there's the 7. And 3 times 4. So look at this. 2 going this way. We've got a 2, a 3, a 4, and a 7. Going this way, we've got a 2, a 3, a 4, and a 7. Did you ever notice that before? Let's see how we can use that. Okay, so here's what we're going to do. We are going to say this one right here is 2 times 4 times 3 times 7. That's that one. Look at this one. That's 7 times 2 times 3 times 4. Now, we know from the commutative property and the associative property of multiplication that if they're all the same sign, in this case they're all multiplication, we can switch them around. So let's put them in order. 2 times 3 times 4 times 7. Look at this. 2 times 3 times 4 times 7. They're equal, aren't they? We don't even have to multiply them out to figure out that 2 times 3 times 4 times 7 equals 2 times 3 times 4 times 7. They're exactly equal. So the cool thing about these numbers in a factor puzzle and also in a proportion is that the crisscross numbers, when you multiply them together, are the same answer. So what that means for this is 8 times 21 equals 14 times p. So we could write this problem as 8 times 21 equals 14 times p. Now, how does that help us? Well, it helps us because we can figure out what 8 times 21 is. 168. 168 equals 14 groups of p. Now we can use what we learned in the last unit. Instead of multiplying by 14, we don't want 14 groups. Remember, we want to isolate the variable. We want one group. We're going to divide by 14. So we're going to do on this side, 168 divided by 14. And on this side, we're going to take 14p and divide it by 14, which means we only have one p left. So p equals 168 divided by 14. Now, the cool thing is about that, we already know that 168 divided by 14 is going to be 2 times 3 times 4 times 7. That's kind of cool, isn't it? So that's called cross multiplication, using cross multiplication to solve a proportion. Now, if you're like, whoa, that was super confusing, not to worry. We'll try a couple more together. Okay, let's take a look at number 3 on page 345. Now, we've got it set up. It's as a proportion. 10 to 25 is equal to t to 15. So it's like a ratio, 10 to 25, and that ratio is equivalent to some mystery number to 15. Remember, we can also write this like this. 10 to 25 is equivalent to t to 15. And it doesn't matter which one we start with, as long as we start with the same. If the first one we start with is the top, then the first one we start with is the top. So if we start with the 10, we have to start with the t. If the second one is the one on the bottom, the second one needs to be the one on the bottom. So there's the 10, the second one is 25, there's the t, the second one is 15. We could also change these sets of 2 colons. We could write it as an equal sign. And what it's saying is this ratio is equal to this ratio. They're equivalent. Now, we could solve this like a factor puzzle. Let me get a different color here. Remember? We just do that, and it looks exactly like a factor puzzle. That's a really good way to solve it. But factor puzzles get tricky if there aren't whole number factors that are making that product. That's why factor puzzles don't work for every single situation. We learn them because they're a great strategy to help us understand multiplication and ratios, but they don't really work well for ones where there is a factor where the factor is not a whole number. In those cases, we use cross multiplication. So here's what we're going to do. We're going to draw those x's. 25 and t, 10 and 15. And now we're going to say if we multiply 10 and 15, it's going to be equal. It gives the same answer as 25 times whatever t is. Remember, you can put the multiplication sign in. You don't have to. You could just write 25t. That means 25 multiplied by t. But you can put it in if you want, 25 groups of t. Now we need to figure out, okay, but how are we going to solve that? Well, we know what 10 times 15 is because we know the zero trick. 1 times 15 is 15. 1 0 in the problem, 1 0 in the answer. So 150 equals 25 groups of t. Now I'm great with my 25s because I'm really awesome with quarters. You might be too. So if you know your quarters, you might say, I don't even really need to figure that one out. I can tell you how many quarters are in $1.50. So if you change it into 25 cents and then this into money as well, that works pretty well. But if you didn't know that, or if it was a number that was trickier, you'd say, okay, now here I am. What do I do? Now this is where you use the inverse operation. You say, this is multiplying 25 times t. I don't want 25 groups of t. I want one group of t because one group is isolating the variable, then it tells me what t is. So instead of multiplying by 25, I'm going to divide by 25 on each side. Because 25 divided by 25 is 1. So 1t just gives us t. What is 150 divided by 25? You might have already known. 4 25s is 100. And then 2 more gives us 150. So the answer is 6. Now, let's see if we can find that as a factor puzzle. Let's see if this one works as a factor puzzle. All right, what's a common factor between 10 and 25? Well, you probably said 5. And I did too. Remember, if it's in the 5 column, it's in the whole 5 column, up and down. 5 times something is 10. Well, I know that's 2. So where 5 and 2 cross is 10, if it's in the 2 row, I know that part's in the 2 row as well. 5 times something is 25. I know that's 5. 5 times 5 is 25. It's in the 5 row, so I put that over here. 5 times something is 15. I know that's 3. 5 times 3 is 15. It's in the 3 column. It's got to be up here too. We know that it's 2 times 5 gives us that answer. 5 times 5 gives us that answer. 3 times 5 gives us that answer. 3 times 2 gives us that answer. Look at that. 6. It worked. That's kind of neat, isn't it? So it gives you 2 different ways to solve it. You can try to start solving them again like we did with factor puzzles at the very beginning of the year, but I encourage you to try cross multiplication to see, and then using the inverse operation to see if you can solve these kinds of problems. All right, let's try one more. This time we're going to have to set it up from the very beginning. We've got 18 2b, remember we read the colons as 2, just like a TO, 18 2b is equivalent to 27 to 33. So we are going to have to set it up as a proportion, and we could set it up as a factor puzzle too. So 18 to b, how are we going to write that? 18 to b is equivalent to, now here's the tricky part. Does the 27 have to go here or here? Does it go on the top or the bottom? Remember, it has to be in the same order, in the same relationship as this one. So this one, we put the 18 on top. So the 27 is the first one in this relationship. It's got to be on the top. Now, Get ready to have your mind exploded. What if I said 18 equals, what if I did 18 on the bottom and B on the top? Is that a disaster? No, it's not disaster at all. But what do I have to do then for this part? I have to make sure that if I put the 18, which is the first number, on the bottom, then I can also have to put this first number, the 27, on the bottom. It's not disaster. I've just got to make sure that I follow those things. Because remember, numbers always mean something. And if this was number of Pringles I ate to number of Doritos I ate, this one, the first number, which was it, Pringles or Doritos? Pringles. So if the first one is Pringles, the second one is Doritos, then over here, the first one is Pringles, the second one is Doritos. So we've got to make sure that we have the Pringles and the Pringles going together, and the Doritos and the Doritos going together. So it doesn't so much matter where these numbers get started down here. It's just that they match up with their other partner numbers. Now, should we solve it with cross multiplication, or should we solve it with a factor puzzle? Or should we solve it with both just for fun? Well, let's solve it with both. All right, there's our factor puzzle. Now, 18 and 27. Do we know a common factor? 9. 9 times 2 is 18. 9 times 3 is 27. Now, if this is in the 2 row, it's in the 2 row down there. If this side's in the 3 row, it's in the 3 row down there. 3 times something is 33. I know that's 11. What's B? B equals 22. Let's see if we can solve that using cross multiplication. And I will warn you, I'm planning on using my calculator to show you this, because I don't want you to have to sit here for a longer video. So it's the top right and the bottom left. The top left and the bottom right. When we multiply those together and set them equal to each other, 18 times 33 equals 27B. So let me get out my phone here. All right, let's see if you can see this. 18 times 33. Can you see that? 594. $594 equals 27 groups of something. We don't want 27 groups, we only want one group. So we're going to divide both sides by 27. That leaves only B on one side. It worked, didn't it? It's kind of a cool thing. And what's even, I think, cooler is that you can see why this works. When I was a kid, they just taught us to do cross multiplication. They said, this works, so just do it. But they didn't show us these factor puzzles, so they didn't show us how the numbers came to be the same. We didn't see that 11 and 2 and 9 and 3, when we multiply those together, 11 times 2 times 9 times 3, we never saw that also it's kind of like two little bones there, doggy bones or something. Look at this, 9 times 2 times 3 times 11. We never saw why that made sense. Why those numbers, those factors, are exactly the same. Isn't that cool? I'm pretty excited about this, and it might be just because I never knew it when I was a kid. So, good luck. I hope you enjoy lesson 4, and we'll see you next time. Bye.